In this video, we'll learn about a few of the quadratic function elements, such as roots, intercepts, and turning points. So I want us to recap a bit and remember where we find quadratic functions. And examples include the trajectory that the ball that you throw upwards forms or follows, and it also links to the area of a rectangle or a square that we've looked at before. So if we think of the dimensions of this rectangle being x, which is unknown, plus 2, so x plus 2, and x plus 4 maybe. So here is x and another 4. 1, 2, 3, 4. You can see squares here, but we don't really know the length of x. So that's 4 there. This whole thing is x plus 4, and this is x. This is x plus 2. So to work out the whole area, we'd go x plus 2 times x plus 4. So that means multiplying x by x, which gives us x squared, and that's represented here. So x times x gives us x squared. Then x times 4, which gives us 4x. So there we have 4, there we have x, so 4x. And then 2 times x, which gives us 2x. And that is 2 times x here. And finally, 4 times 2, which gives us 8. So add 8 to that. Now, how can we plot this onto the graph? So taking what we have here, x squared plus 6x plus 8, and taking some values such as when x is 0, when x is 1, when x is minus 1. So let's try. When x is 0, then we get 0 plus 0 plus 8. As you can see, this is the y-intercept as well, because it crosses the y-axis. Then when x is 1, we get 1 times 1 is 1, plus 6 times 1, which is 6, plus 8. So 1 plus 6, 7, plus 8 is 15. So 115, so this is going to go up here. When x is negative 1, then we get negative 1 times negative 1 gives us 1, plus negative 1 times 6 is negative 6, plus 8. So 1, take away 6 gives us negative 5, and adding 8 to that gives us 3. So negative 1, 3 is another point. When x is negative 2, so negative 2 times negative 2 gives us 4. Negative 2 times 6 gives us negative 12. Add 8. So 4, take away 12 gives us negative 8. Add 8 gives us 0. So we've got another point, which is negative 2, 0. So that is here, negative 2, 0. This is what we call an x-intercept, because the point crosses the x-axis. it's also another thing that we call this, but we'll come to that in a second. Now let's just try when x is -3. So -3 times -3, that gives us 9. -3 times 6 gives us -18 plus 8. So 9, take away 18, leaves us with -9. Add 8, that gives us -1. So we go into -3, -1, which is this point here. What happens when we look at x equals -4? So -4 squared is 16. -4 times 6 gives us -24. Add 8 to that. So 16, take away 24, -8, add 8 gives us 0. So -4, 0 is another point. Now we don't need to work out this because this here is a line of symmetry. This is the lowest point for this curve, so anything on this side will be reflected on this other side. So that should be another point, and where we've got 8 here, so that should be another point. So I'm going to just join these together. You get the idea. So this is an x-intercept, and this is an x-intercept as well. Well, we call these also solutions or roots. So if we plug -4 here and -2 here, we get 0 times 0. So that gives us the roots, the solutions for all of this. So this is how it actually works. This point here is the turning point. It's the lowest point for the curve because it's a positive one. If it's a negative one, that would be the turning point. So here we have the roots, which are also the x-intercepts. Here we have the y-intercept, and here we have the turning point. The turning point is the point where values start changing. So that's the lowest value for y, and then eventually it starts going upwards again.